Alright, so in this video we're going to take a look at simplifying radicals when we have division or a quotient. So there's a couple of different ways to do this. This step 1 is really for part B, so I'm going to skip that for part A. And then again, we're just going to simplify by finding perfect root factors. Since 125 is not divisible by 6, we're just going to go ahead and look for example, 125 has a perfect root factor of 25. So the square root of 25 is 5. 6 divided by 2 gives us 3, so we've got x cubed coming out of the radical. And then under the radical, 25 times 3 gave us 125, and the 6 is still in the denominator because it doesn't have a perfect square factor. So the first thing that I'm going to do is simplify my 3, 6, sorry, that should be a 1, to 1/2. And because I can't have, sorry, I was just checking my steps, because I can't have a radical in the denominator, I do need to rationalize my denominator. So remember, we rationalize the denominator by multiplying by the root that's in the denominator. So now we get 5x cubed, square root of 1 times square root of 2 is square root of 2, over, in the denominator, the square roots cancel, over 2. Alright, last example. This one we're going to jump up to step 1. If they have the same root, sorry, I do have one more example, then you can combine them under one radical, which might be a little bit simpler to take a look at. So we've got x to the 12th, y to the 4th, over 32. You can also keep the roots separate. What's nice about combining them is that if there are any factors that will cancel, you can divide before you simplify the root. In this case, we don't have that, so I'm going to go ahead and simplify my powers. 12 divided by 3 is 4, so x to the 4th is coming out. 4 divided by 3 is 1, and we'll still have y left under the radical. In the denominator, perfect cube root of 32 is 8. Cube root of 8 is 2. Under the radical, we would have a 4 left over. So again, this time, when we rationalize our radical, our denominator, we have to think about the fact that we need to look for perfect cubes that will cancel each other out instead of perfect squares. So it's a little bit more challenging. So I'm going to try and show my work slowly so that you can follow me. The first thing that I'm going to do is recognize that 4 is 2 times 2. So I'm going to change that to 2 times 2. Now in order to cancel my cube root, I need a cube under the radical, a perfect cube. So think about up here, when I multiplied by the square root of 2, one more. Really what I had under the radical, it became the square root of 2 squared, which is why the square root and the square canceled. So I need a perfect cube under my cube root in order for it to cancel. So I'm going to multiply by the cube root of 2 over the cube root of 2. Because I already have 2 2's under my cube root right here, so I need one more to make it a perfect cube to cancel my cube root. So we've got x to the 4th y over 2 times the cube root of 2y in my numerator, and then this 2 cubed will cancel the cube root and come out as another 2 in the denominator. So we've got x to the 4th y over 4 times the cube root of 2y. And this is the last example. We've got 2 different roots, so we cannot combine them under one radical. So we will simplify each separately and then see if there's any way we can combine our final answers. So cube root of 625, the perfect cube factor is 125. Cube root of 125 is 5. and there will be a 5 left over under the radical. 4 for x to the 4th divided by 3 gives us 1, so we have an x coming out with 1 left over. In the denominator, we have a perfect fifth. So we just have the 5th root and the 5th power canceling each other out, and because it's an odd root, our answer would be that negative x. So simplifying, our x's cancel, so we get negative 5 times the cube root of 5x. And your U-try problems.